Hey everyone, this is our lesson on pH and pOH, and by the end of this lesson you should be able to classify substances using the hydronium and hydroxide concentrations. So first let's make sure we understand what these are. So these are measurements of the acidity or the basicity of a solution. So we use the pH scale here. pH is the potency of H+, so how much H+ is present in the solution. pOH is the potency of OH-. So this is measured from Kw, which is the equilibrium constant for water, which you can calculate by the concentration of H+ times the concentration of OH-. And at standard temperature, this is right at 1.0 times 10 to the negative 14th. For an acidic solution, then the pH should be less than 7, which means we have a very high H+ concentration, so 1.0 times 10 to the negative 7th or greater. That means your exponent is going to be -1 to -6, because remember, the smaller the numerical value on a negative exponent, the larger the number is. And then for basic, the pH is going to be greater than 7, so our H+ concentration will be less than 1.0 times 10 to the negative 7th. So we're looking for exponents from -8 to -14. And then neutral is where your pH is equal to 7, so H+ is equal to 1.0 times 10 to the negative 7th. So those are just some values to kind of memorize and know. So there are some important calculations to understand, and I think for those of you who are pretty visual, you may want to pause the video before I go through these and write this picture down kind of on the back or on a piece of notebook paper so that you can have the relationships here to see in a more like pathway form. But if you want to get pH from the H+ concentration, you would use our regular calculation, the one that's on your reference packet, which is pH is equal to negative log of H+. Also, you are never expected to calculate this without a calculator, so make sure you use that. If you want to do the opposite, then to find the concentration of H+, you would do 10 to the negative pH, because we know log is on a base of 10. For pOH and OH-, it's very similar, except instead you're plugging in the concentration of OH-, or you're putting it 10 to the negative pOH. If you want to solve for pH from pOH or opposite, since our scale is on a scale of 0 to 14, our pH scale is 0 to 14, all you do is 14 minus the value that you've been given. So for pH, it's 14 minus the pOH. If you want pH from the OH-, you would have to do pH is equal to 14 minus the negative log of OH-, which is pOH. This one just happens to be more of a two-step problem. Same thing for pOH from H+. So you've got 14 minus the negative log of H+. And then if you want one of our concentrations from the other concentration, you have to use Kw. So to get the concentration of H+, it'd be Kw divided by OH-. One hint here, which is very helpful depending on what your value for H+ is, if it is 1.0, so 1.0 has to be the number out front. If it is 1.0 times 10 to the negative nth power, then your pH is just equal to the n. Okay, so if it's 1.0 times 10 to the negative 6th, the pH is 6. But it has to be 1.0 out front. All right, so let's do some calculations together here. So we are going to calculate the pH, pOH, and OH-. So we want all of those from a solution of HCl with a concentration of 1.5 times 10 to the negative 3. So I like to set this up to show what we have and what we're calculating. So from there, probably easiest to do. You don't need that. I shouldn't. Oh, well. Looking for that. Got that. So the H+ that we have is 1.5 times 10 to the negative 3. Since this is not 1.0, we can't make the assumptions that we have. So next would probably be easiest to do pH. Then from there, might be easiest to do pOH. And then from there, we can do our OH minus. Okay, so to set this up for pH, we know that our calculation is negative log of RH plus, which was 1.5 times 10 to the negative third. So you literally just plug that straight in the calculator. So let me do that myself. Okay, so clear. We're going to do negative log clear. So let's say 1.3, no, 1.5 times 10 to the negative third. Oh, can't do this on my calculator. I don't know why this isn't working. So we're going to plug that in. My calculator is not wanting to work. Give me a second. So you're going to plug this in while I'm getting my calculator to work. We're going to get that. Remember that our pOH is going to be 14 minus the value that we get. And then our OH minus is going to be 10 to the negative pOH that we calculate. Okay, so that should come out if my calculation is working now. 1.82. Oh, and this is a good trick. I should have written this down here as my little clue to the side. Because of the logarithm that you're doing here for sig figs, if you have two values in your coefficient, two sig figs, that means you're going to have two decimal places. So if that calculated correctly, it should be 1.82, which would be a good one for HCl as an acid. So then you're going to take 14 and subtract the 1.82. Which would come out to 12.18. And we're going to take that and make that my exponent on our base of 10. I thought I could do that. Stop. Okay. My calculator is freaking out on me. There. 10. There we go. Oh, I was having such a problem. Equal to 6.6 times 10 to the negative 13. Sorry that took so long, guys. I don't know why my calculator is acting up. So there are the values here. And as long as you're given one of these values and a calculator, that works. then you will be able to calculate any of the other variables that you want. So now I want you to pause the video and try this example. Okay, pause it and try this example. Calculate the H plus concentration, OH minus concentration, and pH of an NaOH solution with a pOH of 2.7. So go ahead, pause the video and try that. So now let's go into indicators, and these change color in solution. So for the four that we tend to look at are red litmus paper, blue litmus paper, universal indicator, and phenolphthalein, which is the one that you'll see in a lab. So for an acid, as you can tell, the colors kind of stay on the red, pink side for the most part. So for red litmus, which is a base indicator, it will stay red. Blue litmus will turn red. Universal indicator is like pink, red, orange. And then phenolphthalein will actually stay clear. It's a clear liquid. It'll stay clear in an acid. Then for bases, they stay on the cooler side, so the blues and the purples. So red litmus will turn blue. Blue litmus will stay blue. Universal indicator will turn in those blues, purples. And then phenolphthalein, actually, like this GIF down here at the bottom, will turn pink in a base.